Welcome to Papa Junk Shop. Got another battery to check out. None of these batteries are given to me, so it's not like a company is sponsoring me or anything like that. So you're gonna hear what I think about them for real. So this one, I guess, is LOSSIGY, and it's a 12 volt 15 ampere hour lithium iron phosphate, and got some nice information here. It's really lightweight. Come with caps for out over the terminals, and it had a couple of jumpers with it too. So the specs are on here, but the background makes it a little hard to read, and I don't have my specs, so let me get a magnifying glass here. Let's see. Nominal capacity 15 ampere hours. Watt hours, maybe I should have a light on too. Yeah. 192 watt hours. Charging voltage 14.6. Discharge current 15 amp max. Standard / max charge is 3 amps / 15. Operating temperature 0°C to 50°C. Discharge -20°C to 60°C. Store at greater than or equal to 50% capacity. Recharge every 3 months. So it's nicely constructed, and I charged it until the BMS shut off, and it shut off at around just a whisker over 15 volts. And let's see, I got my meter here. It's been sitting for a bit, so let's see what the voltage is here. .72. Okay, so I'm going to put about a 3 amp load on it, which would be a 0.2C. And I got my little meter here, and inverter, amp meter, and this is about a 3 amp load. So we're going to let her run and see how she does. So let me get her hooked up and I'll be right back. I didn't mention it's got pretty nice terminal bolts here. There is a washer and a split washer there, so, and they're fairly long for the size of the battery, so, and the terminals themselves look pretty nice. Okay, got her hooked up. Let's fire her up here. So that's just the inverter on, and this meter is not, yeah, it's pretty close, isn't it? It says 13.6, 13.6, no load though. We're only going to be drawing 3 amps, so these cables should be plenty adequate. So I'll get this thing reset for 0. I goofed. There we go. Okay, now we're all set for 0. So let me turn on the load. Okay. So we got what? 27.4 watts. That's pretty close. And we're just about 3 amps. As soon as that voltage drops a little bit, it'll be at 3, I'm sure. And towards the end, it'll probably be a little over. So I'm going to mark down the time. We'll see how long it runs, and how many watt hours we get out of her. So, see you in a bit. Okay, we're into the first hour. Still at 3 amps. The inverter voltmeter says 12.9. See what the fluke says. It says 13.01. And we've got 30.3 volts and 31 watt hours. So check in hour 2. Okay, we're into hour 2. We're still at 3 amps. 12.7 on the inverter. Let's see, the fluke meter right on the battery is 12.89. And we've got still 30.1 watts and 63 watt hours. So we'll check in hour 3. Okay, 3 hours. We're at 3.2 amps now. And the inverter says 12.6 volts. The fluke says 12.8 volts. That's right at the battery. And we've got 30 watts and 89 ampere hours. So see you in another hour. Okay, we're at hour 4. And we got what, 3.5 amps now. The inverter voltage says 12.2. The fluke says 12.42. And we got still got 30.1 watts and 120 watt hours. So we'll come back in another hour and check on her. We're at 4.5 hours. And we got 3.8 amps now because the voltage is dropping. And we got 10.6 volts on the inverter. And let's see, Mr. Fluke here wants to be reset. 10.74 there. We still got 30.4 watts and 136 watt hours. So start keeping an eye on it, I guess. Well, it's only been a minute. We're down to 10.2 and we're getting a flash on the inverter. .1. I almost turned the camera off. It's going to wait a bit. If you can see the two, there she goes. So it was 4 hours and 33 minutes. The inverter shut off. Okay, so I'm going to find a DC load to put on it, and we'll run it down a little more until we get the thing to the BMS to disconnect. Okay, I got a little car headlight bulb hooked up to it. It's drawing about 4.5 amps, so we'll see how long it goes. Okay, we're down to 10 volts. .8. .6. 9.6 she went off. Okay, as soon as I unhook the load, the battery voltage come back up. So that only took what, about a minute or so. Okay, so I'll plug this into regular electric so we can see what the watt hours were. Yeah, 136 watt hours. So now we got loss in the inverter, and I figured it out with that small a load on it. It was only about 80% efficient, so I'd have to add about 20% more to it. So that would be what, 13.6 times 20%. 27.2. Let's say, give it the benefit of the doubt, say 28. So that's 4, 6. So that'd be 164 watt hours. And the battery said what, 192. So if you add the DC amps, we get 3, 6, 9, 12, and then a half an hour. It'd be 13 and a half, 14. Yeah, come up about 14.2 ampere hours if you do the DC amps. So yeah, I'd say it, you know, this isn't a real accurate setup, but I'd say it pretty much does its advertised ampere hours. So just for the fun of it, I'm gonna charge it back up again, and it says maximum load is 15 amps, so we'll figure out a 15 amp load and see how long it'll run that. But won't be today, so we'll be back tomorrow and try that. Okay, next day, got her all charged up again. I got a 15 amp load figured out on the DC side. So we'll get started with a full load test. Battery's at what, 13.67. That's according to the Fluke. So turn on the inverter. Get this meter reset. Okay, so we're all set back to 0. Make note of the time. And turn around. Okay, so we got 15.5 amps. And we got 183 watts. So probably check like every 15 minutes or so. So see you in 15, see how we're doing. Okay, we're into 15 minutes. We're still at 15.5 amps, and voltage is 12.29, and the watts is 185, and the watt hours are 49. Well, just changed to 50, so back in another 15. We're into half an hour now. We got 16 amps. And we got 12.12 volts. And we got 188 watts. And we got 101 watt hours. So another 15. Okay, we're up to the 45-minute mark. We are now at 17 amps. The voltage is at 11.27. We're 186 watts and 145 watt hours. And the voltage is dropping pretty quick. Now I did notice too that right here the battery is actually getting warm. I don't know if that's where the BMS is, maybe? I don't know. But let's see. Let's see, this rubber mat's at 65.4. And that battery case is at 95.3. So there is a little warmth there. But we are exceeding the maximum capacity by 2 amps for the last few minutes here. I'm down to 10.92. I'll just let the camera run here and we'll watch. Voltage is dropping on the inverter some. We're down. Okay, the inverter just started complaining. We're at 149 watt hours, which exceeded the low amperage draw. Okay, we just hit 150 watt hours. 10.72 volts. The inverter showing 10.1, 10. These terminals weren't warm at all, so, oh, there she goes. Okay, so, let me plug this into regular power. So we can see what the meter says. I think it was 150. Yep, 150. Well, yeah, it was 150. So, when we did the 3 amp test, we got 136. And here we got 150. So if I figure the inefficiency of the inverter and add that to it, we wind up with about 180. So yeah, pretty close to the specs on here. Like I say, my setup here I'm sure is not the most accurate thing, but pretty much does what it says it'll do. So, and there's a little bit left in it because the inverter actually shut down. So I'd say it probably meets its specs. I think just for the fun of it, I'm going to take my ADC 16 ampere hour battery and do the same identical test just for the fun of it and see how it does. So I'll see you in a little bit. Okay, swap the batteries out. This one's at 13.69. Yeah, the other one was what, 13.67. So, got the inverter on. We'll get this meter reset. Okay. And mark the time down. And fire her up. There we got the 188 watts. 12.021. 12 volts. Boy, it seems like that's dropping awful quick. See, I don't have it ready. No, it says 11.92 already. We're at 16 amps. Well, let's just see how she does. Be back in a bit. Okay, we're 15 minutes in. We're at what, 16 amps, 12 volts. That's weird that the voltage actually come up. And 47 watt hours, 188 watts. So we'll check in on another 15. We're at the half hour mark. What, 16 amps, 11.95 volts, 102 watt hours, 187 watts. Doing alright so far, so check in again in another 15 minutes. Okay, we're at the 45-minute mark, and we got a what, 16 and a half amps, 11.55 volts, 148 watt hours. So compared to the other one, we're 2 watt hours ahead. 1/2 an amp less, and the voltage is about 0.3 volts higher. The other one gave up at 150 watt hours. It shut down, so we'll let her run here a bit and watch. Okay, we just reached 150 and we're still going. The inverter says 10.8. The fluke says 11.48. And this battery is just a little bit warm too. Let's see, the mat here on the bench is at 67, and that case right there feels warm just like the other one a little bit. That's at 88, so not quite as warm. So I don't know whether to leave the camera run or wait till it gets a little closer. I'm going to shut you down for a minute or two. If it gets close, I'll turn it back on. Okay, it's been a few minutes. We're down to 10.3 volts on the inverter, and it's getting excited. We get a little blink and a beep. We got 162 watt hours. The fluke says 10.88, and we're still at 16 and a half amps. 10.1 volts on the inverter. $163 watt hours. There she goes. Okay, so we had 163 watt hours. The other one we had 150. But this one is 12 watt hours more because it is a 16 ampere hour. So we actually got 1 watt hour more out of this battery than the other. So I would say they're pretty close to the same quality. They both do pretty much what they say they're going to do. So I guess this has probably been a long enough a video. So I'll let you guys draw the conclusions, but I'd say either one of these batteries are a safe bet. Like I say, with my crude test setup, all the inefficiencies and everything, you know, they did well. They're both seem nicely constructed and don't really have anything bad to say about them. So if you enjoyed this battery comparison test, whatever you want to call it, give me a thumbs up. If you haven't subscribed, please do. Thanks for watching, and we'll see you next time.